You're on an operating table, lights glaring like a movie set, a scalpel gleaming above you. Yet, you feel nothing, no pain, no fear, just a void deeper than sleep. That's anesthesia at work. But here's the jaw-dropping truth. After nearly 180 years, science still hasn't cracked its deepest secrets. It's one of medicine's greatest mysteries, and today, we're rediving into the brain's hidden mechanics to uncover how it pulls off this magic trick. Stick with us, because what we're about to reveal might reshape how you view your next surgery or even the future of human consciousness. Welcome to our deep dive into how does anesthesia work. If you're new here, smash that subscribe button. We're all about cracking open science's wildest puzzles with stories that hook you from the start. Let's get to it. Anesthesia isn't just a knockout drug. It's a precision tool that lets surgeons work miracles inside your body. But to understand its power, we first need to tackle the big question. Why is switching off consciousness so complex? And why has it stumped experts for centuries? The core mystery lies in the brain, a network of 86 billion neurons firing like a city's electrical grid, creating the symphony of thoughts, feelings, and awareness we call consciousness. Anesthesia docenti just dim the lights. It selectively silences parts of this symphony, while keeping vital systems like your heart and lungs running. How? Let's break it down into three key areas. The science we know, the gaps we're still exploring, and where this could take us in the future. First, the science of anesthesia as we understand it today. Since 1846, when a dentist named William Morton used ether to knock out a patient for surgery, anesthesia has been a game changer. Today, we use a cocktail of drugs: propofol, ketamine, nitrous oxide, and others to achieve three main goals: unconsciousness, pain relief, and muscle relaxation. Here's the crazy part. These drugs don't just shut your brain off like a light switch. They target specific regions, like the thalamus, which relays sensory signals, and the cortex, where consciousness seems to live. Studies from places like MIT in 2024 show anesthetics disrupt communication between these brain regions, creating a kind of temporary static that halts awareness. One key player: GABA receptors, the brain's brake pedals. Drugs like propofol crank these up, slowing neural activity to a crawl. Meanwhile, other drugs block glutamate, the brain's accelerator, keeping you in that eerie state of oblivion. But here's the kicker. We know these drugs affect neurons, but we don't fully grasp why some people slip into unconsciousness, while others don't, even with the same dose. It's like trying to solve a puzzle with half the pieces missing. Now, let's talk about the gaps, the stuff that keeps neuroscientists up at night. Despite all our tech, we can't pinpoint exactly where consciousness comes from. So we're still guessing at how anesthesia turns it off. Is it just about GABA and glutamate, or is something bigger at play? A 2023 study in Nature Neuroscience suggested anesthetics might disrupt something called neural synchrony, the rhythm that keeps brain regions talking to each other. Think of it like an orchestra losing its conductor suddenly. The music falls apart. But here's where it gets wild. Some patients under anesthesia still show signs of awareness, like responding to commands, even though they don't remember it. This is called connected consciousness, and it's rare, about 1 in 1,000 cases, but it hints that anesthesia might not fully turn off the brain. Instead, it might trap you in a weird limbo, where you're re-aware but can form memories. Creepy, right? And then there's the dose problem. Factors like genetics, body weight, or even stress can change how anesthesia works, which is why anesthesiologists are basically real-time brain hackers, adjusting doses on the fly. Yet, we're still flying partly blind, relying on trial and error more than we'd like to admit. So, where's this all heading? Let's peer into the future. As we speak, AI and brain mapping tech are revolutionizing how we study anesthesia. Tools like neural networks modeled on the brain itself are analyzing massive datasets from EEG scans and fMRI machines to predict how patients will respond to drugs. A 2025 report from Stanford highlighted how AI models can simulate brain activity under anesthesia with 85% accuracy, helping doctors tailor doses to individuals. This could mean fewer risks, like waking up mid-surgery or lingering side effects. But it's not just about safer surgeries. Understanding anesthesia could unlock the secrets of consciousness itself. If we crack how to turn it off and on like a switch, we might one day control states of mind, think curing depression by rebooting neural pathways or enhancing focus by tweaking brain rhythms. Some experts even speculate we could use anesthesia-like tech to induce hibernation states for long space missions. Imagine astronauts snoozing through a trip to Mars, their brains in a perfectly controlled stasis. While skeptics argue we're decades away from such leaps, breakthroughs in neural mapping suggests we're closer than ever. Now, let's get speculative for a moment. Picture this. It's 2040, and anesthesia isn't just for surgery anymore. Scientists have mapped the brain's consciousness code, and we've developed a device, let's call it a neuroswitch. It's a tiny implant that uses anesthesia-inspired tech to toggle your brain's state. Need to sleep instantly? Flick the switch. Want to enter a hyper-focused flow state for work? Switch again, feeling anxious? Dial down the amygdala's chatter. This isn't sci-fi fantasy, it's a plausible extension of today's research. Companies like Neuralink are already working on brain-computer interfaces, and a 2024 X post from a neuroscientist at Caltech predicted we LLC consciousness-modulating tech by the 2030s. But here's the flip side. What happens when this tech falls into the wrong hands? Could governments or corporations control our minds, turning us into obedient drones? It's a chilling thought, but one we need to wrestle with as this science evolves. What do you think? Could we handle that kind of power? Drop your thoughts in the comments below. Let's zoom out. Anesthesia isn't just about knocking you out. It's a window into the greatest mystery of all. What makes you, you? Every time you go under, you're part of an ongoing experiment, helping us decode the brain's deepest secrets. And with AI accelerating our discoveries, we're on the cusp of a revolution that could redefine medicine, space exploration, and even how we live our daily lives. But it all hinges on solving that one big puzzle. How do a few chemicals plunge you into oblivion and bring you back unchanged? Before we wrap up, let's address a common worry. Is anesthesia safe? The data says yes, modern anesthesia has a failure rate of less than 0.01%, and deaths are even rarer, about 1 in 100,000 cases, per a 2023 study from the American Society of Anesthesiologists. But risks like allergic reactions or awareness during surgery still exist. That's why anesthesiologists train for over a decade to master this delicate dance. So, next time you're counting backward from 100, trust that you're in good hands even if science is still catching up. We've just scratched the surface of this mind-bending topic. If you loved this deep dive, hit that like button and share this video with anyone who has ever wondered what happens when they go under. Subscribe and ring the bell so you don't miss our next journey into science's wildest frontiers. And tell us in the comments, what's the weirdest thing you've ever heard about anesthesia, or what future tech excites you most? Let's keep this conversation going. Until next time, stay curious and keep exploring the unknown.